So we've been trying to find the best linear trend line. And I have a secret for you. This is actually the definition of linear regression. Congratulations. We've been doing linear regression. So linear, that makes sense. Regression, why is it called regression? If you look it up on Wikipedia, regress means to go backwards, to go past, to the past. That's really not what we're doing at all. I encourage you just to think of this as a quirk in the English language. It's called linear regression. Linear makes sense, regression does not. It's just the word that we use to mean finding the best linear trend line. And we did this in two ways. We first minimized the total absolute error, which for us, remember that our equation was r of I is equal to the slope m times the day I plus b. So we went through and tried a whole bunch of different slope and y-intercept combinations. And to minimize the total absolute error, the equation that we found was, r of I is equal to slope of 0.6 times I plus a y-intercept of 4.5. So in more mathy terms, what we actually did was what we were doing was to find m and b that, and this is admittedly confusing, but this is the math phrase for the English version of minimize the total absolute error. So we minimized the sum from I of 1 to n of the absolute value of h sub I, the measured hours of sleep, minus our equation r of I. Find m and b that minimizes this right here is the total absolute error. And then the second way that we did our linear regression was we minimized the total square error. And oh look, it's June. This is June. Oh, there she goes. Say hi, June. All right, so sorry about that. To minimize the total squared error, we found that our equation was r of I equals 0.6 times I plus 4. And then, nope, sorry, we have a puppy in the way. June, no, come here. Over there. So what this means is that we found the m and the, okay. This is r of I. The m and the b that minimized the squared error. So these are both valid methods to do linear regression. One is not necessarily better than the other, they're just different. And in fact, there are some other ways to do linear regression that I won't get into. And now let's go ahead and write our prediction for the 7th hour, or for the 7th day. So using the total absolute error, we'll plug in r of 7 equals 0.6 times 7 plus 4.5. And I had to use a calculator. This turns out to be 4.2 plus 4.5 equals 9.7. Excuse me, 8.7. And then using the total squared error, we'll find same slope, 0.6 times 7 plus 4, which is equal to 4.2 plus 4, which is equal to 8.2. So here are our two predictions. Using the total absolute error, we'll think that June will sleep almost 9 hours on day 7, and probably closer to 8 hours using total squared error. Which one is better? And there's really no way to know until we just wait till the 7th day. And that's kind of what you have to do when making a model for predictions. You don't really know which one is better until you actually measure the data. One thing I can tell you is that using the total absolute error, and I think I'll make another video to show some examples of this. Using the total absolute error makes intuitive sense. So this is a nice part about using the total absolute error. We know that the total absolute error is the total distance that we had to travel from our, here's our points, here's our line. The total absolute error is the total distance we had to travel from the points to the line. We just add up all these distances. When we do the total squared error, we cannot do that. And in fact, one quirk of using total squared error is that it's sensitive. It's sensitive to outliers. Oh, I always spell that wrong. Outliers? I think that's right. So what I mean by this is, let's say we have some data that looks like this with a clear linear trend down here. But then we've got a couple of points way up here. If we were using the total absolute error, this distance to our, let's draw a trend line. I'll use red. Let's draw a trend line right here. So this clearly matches most of our data here. Using the total absolute error, we'll just weight these points the same as any other point. When using the total squared error, this distance, let's say this is a distance of 10, this gets squared. So all of a sudden the punishment to our trend line is a 100. And this means that our trend line may actually kind of squeak up towards the outliers. It's sensitive to outliers. It's pulled up or pulled down due to the outliers. So you just need to be aware of that when you're using total squared error. One is not necessarily better than the other, but they are different. So keep these differences in mind. Thanks.